Welcome back, everyone. So for this second part of the LCA workshop, we'll be looking at a practical example of LCA. We selected this case of olive oil for cooking, and me and my colleague Francisco will be first presenting a couple of slides just to give an overview of this system that we'll be discussing. Then I'll transition to the Excel file that was sent this morning to look in more detail how to build the inventory and also to see some results that can be extracted using this methodology. And to finalize, we'll be looking at the software that we use to model this example, and also that will be used to model the case studies for the project. So in this example, we'll look into the definition of the golden scope. We'll develop the life cycle inventory, which will include the various inputs and outputs for the system. We'll calculate the environmental impact using emission factors that we've taken from the databases that are available. And after calculating those results, those impacts, we'll interpret the results in order to analyze what's the environmental impact of the production of the olive oil. Also, to see how we can compare the results of this particular product with other similar products such as rapeseed oil or palm oil, and also identify the most focal points of interest in order to develop an improvement scenario for a more sustainable olive oil production. So regarding the goal and scope, the main goal of this example is to determine the environmental impacts of the use of olive oil for cooking. And in order to be able to have these analyses, we need to do a cradle to grave approach. So we need to consider all the inputs and outputs from the production of the raw material, in this case the olives, and till the end of life of the used oil after it is utilized for cooking. If our goal would be different, for example, if our goal was only to determine the environmental impacts of the production phase of the life cycle, then we could have opted for a cradle-to-gate approach instead. So because we are looking at the complete life cycles of the olive oil, we want to establish a functional unit which will be used to then compare all the results and establish the values that will be collected for the inventory. We need to establish a functional unit that characterizes the whole system. And in this case, one of the alternatives is to establish it as 1 liter of olive oil for deep frying. But we could also have used, if, for example, we wanted to study a particular kitchen, we could have established as the amount of olive oil that kitchen uses daily or weekly or during a year. It was also that type of analysis can also be done. And if it were looking only to the environmental impacts of the manufacturing stage, instead of this functional unit, we could have established it as a function of the amount that is produced for that manufacturing process. So the amount that the manufacturing installation can produce during a year, for example. By establishing this functional unit, we are able to compare the impacts of the olive oil with other cooking oils, and also determine the main causes for the impact, what life cycle stages are more important, and also what are the impact categories that are more relevant. So regarding this system, it will, being a cradle-to-grave approach, will include all the life cycle stages of olive oil, which include the olive production. And in this stage, we have fertilizers, irrigation, also agricultural machinery that needs to be used. Then we go to the extraction stage in order to produce the olive oil from the olives. And here you use various processes such as washing, brushing, centrifugation in order to be able to separate the virgin olive oil. Then that olive oil needs to be packaged. In this case, we'll be using PET bottles, and those PET bottles are then grouped into sets using cardboard boxes, which are then transported by lorry to the point of sale, where the users of this product will buy the olive oil, use it for cooking, and after it is used, it needs to be disposed of using treatment processes that are adequate in order to avoid leaking and releasing this used oil in the environment. So, regarding the inventory analysis, we normally divide the inputs and outputs into these 4 groups. The first is inputs from nature. This includes all natural resources that are directly extracted from nature. There's no processing done for these inputs. Is directly they are directly extracted. Then we have materials and inputs that come from the technological sphere that are made by man. So which include raw materials, water, fuels, and we also normally separate energy, which can include heat, for example, using natural gas or electricity that is produced using a variety of technologies. And finally, we have the outputs, which include the wastes from the processes and also the emissions. So just to go briefly look at each life cycle phase of this example, then we'll look into more detail using the Excel. So just to have a brief overview, the first phase is the olive production, where we have, as I said, fertilizers, other agricultural products, irrigation, the land that is used, and also the equipment that is required. And then for emissions, we identify ammonia, carbon dioxide, nitrate, and waste wood. Regarding carbon dioxide, because we're talking about an agriculture activity, which has some sequestration of this gas, we also include carbon dioxide in the inputs in order to have that environmental benefit accounted. For the next phase, we utilize the olives, which are the main input, and also the other inputs required for those processes that I listed previously. So that are water, propane, hexane, and also electricity. In this example, we'll be using the conventional mix for Portugal, but we also then replace it with renewables energy to see what improvements we can get by using a different energy source. And regarding the outputs, we have carbon dioxide, wastewater, and also bio-waste. Here this bio-waste is olive pomace, so it needs to be treated accordingly. Then we'll package the olive oil using PET bottles and cardboard boxes, which is then transported by lorry, and we also have to account for the electricity that this packaging process entails. And then regarding emissions, for these processes, normally the databases have a significant amount of information regarding these processes that can be utilized unless we wanted to test something very specific. In most cases, those processes can be utilized and already include emissions. So for these processes that we already have information in the databases, it is not really necessary to collect information, for example, in emissions, because they are already counted. If you also included emissions outside of these processes, we'll be double counting those impacts and the results will be incorrect. And finally, we have the use phase and the end of life. For the use phase, the only input it's also the olive oil, of course, but it's also heat from the natural gas. And then as output we have the used vegetable oil, which will be sent to the end of life treatment. So by collecting all these inputs and outputs, we can then give them the correct emission factor for the different impact categories and calculate the results. We can calculate the results in midpoint, meaning we quantify the substances that are released for the environment and that are specific for each impact category. And we can also obtain the results in terms of endpoint, meaning the damage that is done to human health, ecosystems, and also resources. In the interpretation of the results, we'll be able to see the impact of olive oil, the environmental impact of producing and using olive oil for each life cycle stage, and also in different impact categories, allowing us to understand what are the impact categories that contribute more to the overall impact, and also identify what life cycle stages have a greater weight for each impact category. These overall environmental impact can then be compared with other types of cooking oils that are equivalent to this product that is being studied. And finally, by identifying the most important points on the system, we can define some measures, some changes that are able to improve the environmental performance. So now, before I go to the Excel to show the inventory and the results, does anyone have any question?
I have a question, João, but maybe you are going to answer it later. But if the electricity is used from renewable sources, for example, does that have an impact in the LCA? Yes.
So the electricity is one of the processes that we normally use the information that is already available in the databases. So the databases have information on the electricity mix for different countries, for example, Portugal, Spain, Italy, etc. with data specific for the energy sources that are utilized on those countries, and also as products processes that are specific for technology. For example, there's a processes specific for photovoltaic panels, eolics, and other renewable sources. So those processes include all the infrastructure required to produce that energy and also all the emissions. And when we introduce those processes in the LCA models that we prepare, and we introduce the amount of electricity that we use, the model automatically calculates what is the impact associated with using that energy.
Okay, thank you.
So if there are no more questions, I'll start sharing the Excel. I think everyone is seeing my screen.
Yes.
So here in the Excel, we have the system that we are analyzing, that I described in the slides. Just to remember, the functional unit that we established is 1 liter of virgin olive oil used for cooking. And for this example, we selected these 4 impact categories to have our results. So we selected global warming potential, terrestrial ecotoxicity, mineral resource scarcity, and also water consumption. We selected these impact categories. First, global warming potential is one of the most used indicators for evaluating environmental impact. It's known by most people, even people that are not practitioners of LCA. Then we also use terrestrial ecotoxicity, water consumption, and mineral resource scarcity because of this being an agriculture activity. So it involves the use of water, also the fertilizers that contaminate the soil. So these are important impact categories to study. In the next sheet, we have the life cycle inventory. So it shows how we can build the life cycle inventory. So we usually divide it by the life cycle stages and also by the different nature of inputs. So these are the inputs that we've seen in the slides. So inputs from nature, natural resources, the inputs from the technological sphere, the materials, water, and fuels, and also energy, and then the waste and emissions. There's also a 5th category of inputs, which are avoided products, which normally are used to when the processes that we use enable us to replace a raw material, or for example, the example that Anna gave, a process that receives waste and transforms it into energy. By producing that energy using that waste, we are avoiding the producing electricity by using other natural resources, and so we are avoiding the impact of extracting those resources, and as such, if we consider here avoid that electricity that generates as an avoided product, we can give that benefit, that environmental benefit, to the process. In the improvement strategies, we'll look into the avoided product of ethanol produced by the olive pomace. So we use one of the wastes that result from the extraction process as a way to produce a different type of product that will result in a benefit to the environment. So looking at the different life cycle stages, these are the inputs that we identified in the slides. Important to something that's very important during the inventory data collection is to look at the units that we'll be using. So, for example, in this first life cycle phase, we establish the units for all the inputs as the amount of the parameter that we'll be using per the amount per kilogram of olive oil. So all these inputs are for 1 kilogram of olives. Then when we start modeling the next life cycle phase, we, because the functional unit is 1 liter, we then introduce the amount of olives that we need in order to produce the 1 liter of olive oil. And all the other inputs for this stage are defined as that, as the amount needed for 1 liter. And the same is equal to the following life cycle stages for packaging, for distribution, for the use, which we have heat from the natural gas, and the end of life. The cells that are here in green are the cells where you can change values, and Excel will calculate the impacts based on the values that are introduced. So, for example, these cells here in white are all considered here in the olive. So, if we want to change something related in this sheet related to the first life cycle stage, we need to change here in the olives. So, okay, I think there's a question.
Yes. I can understand that the perimeter here is on the production of the olive oil. Okay. So that means the machinery itself does not come into account in this particular example.
In this particular example, yes, we do not include the machines, the infrastructure required to extract the olive oil, but it's a possibility. So if we add that information, we know that the machine is able to produce during this life cycle an X amount of olive oil. We can allocate the impact of that life cycle of the machine to 1 liter of olive oil produced.
Do you generally link for example, the machine life cycle? Would you link it to the accounting life cycle of the machine, where, for example, it's fully depreciated, or would you say that you delink completely these two things?
I'm not sure if I'm understanding the question.
Well, let's say a machine is fully depreciated in 10 years. Are you using the 10 years for the productivity of the machine, or are you using the fact that, or are you using a different metric? For example, if you know the machine can work for 20.
We would use the 20 years. So it's we'll look always to the life cycle, that meaning the amount of olive oil that the machine can produce during its life cycle, and we will account for the 20 years to have it correctly allocated to 1 liter of olive oil.
I understand. Thank you.
Okay. Is there any other question? Okay.
Yes. So, João. Can I ask a quick question? How do you obtain the values for the inputs? Are the companies that provide to you?
Yes. In some cases, for example, in the case that we are in Flash, we'll try to get these inputs from the partners. So, for example, the information here regarding production, we would like to have information specific for the production processes that will be done by the partners. Regarding other life cycle stages where the partners are not as involved, so they might not have as much information, we can also collect information that data from literature. So there's already other studies that did something similar, and we can use that data in order for our model, and also the databases that are available already have some processes that, if there's no other type of information available, we can use that process as the most representative for the system that we are studying.
Thank you.
Okay, so moving to the results. So here in the first graph, we have the total impact in midpoints. So this is the characterization. So every the category impacts, the impact categories, sorry, have the unit associated with each category. So we have global warming potential, with each characterized as kilograms of CO2 equivalent. Then we have terrestrial ecotoxicity, that is characterized as kilograms of this substance, DCB. Then we have mineral resource scarcity, which is characterized as kilograms of CO2 equivalent. And finally, water consumption in cubic meters. So for considering those inputs that we've seen in the previous sheet and the emission factors that are associated with these four impact categories, we are able to calculate these results. So we the whole life cycle of producing and using the olive oil results in the emission of 1.06 kilograms of CO2 equivalent, the emission of 8.89 kilograms of DCB. It results in a requirement to extract additionally 0.01 kilograms of copper equivalent, and it involves the consumption of 0.3 cubic meters of water. Because each impact category has their own unit, when we are looking at characterization, we cannot compare them. We can only look at and analyze each impact category individually. But when we do the normalization, so we divide by a normal value, as my colleague Anna explained, we start to be able to compare between different impact categories. So here we can see that the water consumption is one of the most important impact categories for this example, followed by the terrestrial ecotoxicity, and then by global warming potential. And we can see that regarding mineral resource scarcity, the life cycle of olive oil is not very intensive in this particular impact category. And then we can also see the normalization at endpoint. So now we convert these impact categories into their effective damage in the endpoint categories, which are human health, resources, and ecosystems. And we can see that the environmental impact is primarily associated with damages to human health, followed by ecosystems, and as expected, because as we've seen in the midpoint results, resources is not very significant for this example. Other analysis that we can also do is to see the contribution of each life cycle stage for the impact in the impact categories. So, for example, in water consumption, we can see that the production stage, so the production of olives, is the stage that contributes the most. So the others are mostly irrelevant in this impact category. If you look at terrestrial ecotoxicity, production of olives continues to be the most, continues to have the largest contribution, especially because the use of fertilizers and other products that then are released are accumulated into soils. But we also see a larger contribution for the extraction stage. And in the case of global warming potential, we see that in this case, the olive oil extraction is the stage that has the most contribution, especially because the use of electricity, which normally involves some emissions. And we can also see the same results expressed in endpoints, and here the olive oil, the olive production. So the first stage is always the one with the most contribution. So then I'll just show how we can use this information, these results, in order to introduce some changes in the system and trying and produce a more sustainable product. So for the same changes, we selected reduction in the use of fertilizers and plant protection products. So we reduced the use of these by 30%, and we also reduced the use of water by 50%. And this is all the changes that we've done to the first life cycle stage. And then for the second life cycle stage, we replaced the electricity. In the first example, we are using the energy from the electricity from the grid, and now we replace it with a totally renewable source, photovoltaic, and we also remove instead of sending the BOS, the olive pomace, to a treatment, end of life treatment, we use a process that can use that byproduct in the production of ethanol. And so now this ethanol does not, that amount of ethanol that can be produced using that byproduct doesn't need to be produced by normal raw materials that were structured from nature, and we have avoided that impact, and so it's accounted here. I think it's all, so we can now go to the results, and here we see the comparison between the conventional process that we saw first and the improvement. We see that generally the improvement has a lower environmental impact, for example, in global warming potential, in terrestrial ecotoxicity, in regarding mineral resource scarcity is mostly the same. It's not very relevant for this case, and but we saw that it resulted in an increase in water consumption. So in order to understand this behavior, we can look at the impacts for each life cycle stage. And so we see that by introducing these changes, in the case of global warming potential, we are able to remove a significant part of the impacts related with the olive oil extraction chain. So this is done primarily by replacing the energy source. So by using renewable energy, we are reducing the global warming potential. Regarding terrestrial ecotoxicity, we see some decrease in the olive production stage, meaning removing some of those fertilizers and other products was successful in improving the environmental performance. But we saw that by that reducing the irrigation was able to reduce the environmental performance associated with water consumption. However, we started having a significant amount of water consumption in the olive oil extraction stage. This occurs because we are using photovoltaic energy, which in order to keep the efficiency of the equipment high, it's necessary to wash regularly the panels, and as such, that water that is used, it's accounted here. So in this case, in order to reduce these impacts, we'll need to consider recirculation systems in order to reuse that water multiple times, and so have a real improvement in this indicator. And finally, here we can see just for each impact category how the changes we made resulted in improvement or worsening in some cases of the environmental impact. So, for example, in global warming potential, we can see that by replacing the biowaste treatment with ethanol substitution, by ethanol production, we can reduce the environmental impacts. And in this case, we have the stage for olive oil production ends up with a negative value, meaning that in the end we have an environmental benefit in this process, and the same can be seen for the other impact categories. So you can see that ethanol has a significant improvement in the environmental impacts, and removes the impacts associated with the treatment of the biowaste. I think that's all. I don't know. Does everyone have any question about this example? Okay. So now we'll transition to the CIMAPRO software just to see how it works. So,
thank you, João. Okay, can everyone hear me? Yep, we have a question. Yes.
So what will be the steps forward to move from olives to medical devices, car manufacturing, and complex laser systems?
Exactly. Okay. So, sorry. Okay. I think now you're hearing me. Okay. So, while this example is not directly related with the use cases that we have in the project for Flash, the methodology and the steps that we'll go through are very similar. So that inventory that we have for olive oils with the different life cycle stages, the different type of inputs, will be very similar to what we need for each use case. So we'll have the different type of inputs, the different life cycle stages for each use case, and then we'll see each use case uses different parameters. So it uses electricity, has some waste from the piece that results from the process, and so all of those will be characterized in the same way we've seen in this example, and used to calculate the results for their life cycle. And then regarding the impact categories and also the question of improvements, the results will also be presented in a similar way. So we have these several impact categories. We might be using other ones because they're more relevant for the use case. So that's something that will be defined, what impact categories we'll be looking at. But then the results will be presented similarly. So we'll have the impacts for each impact category. We can have the impacts shown by different stages. So the production, the use, etc. And then we can see for the processes, for the medical case, for the automotive case, what is the most important life cycle stage, what are the most important impact categories, etc.
There's another one. There is a question in the chat.
There's another question.
How do you ensure harmonization of the results across industries in order to allow fairness between LCA done by different organizations, companies? Are there standards that we can refer to in order to ensure that we are actually comparing the same thing?
Okay, so regarding standards, we presented in the introduction for LCA the standards that are usually used. I can show you again the slide just so that you can see. It's this slide. So these are the standards that are used to define how to do an LCA. Regarding harmonization for different industries, etc. So that's one of the limitations of LCA, is that when we define the goal and scope, when we define the functional unit, and we collect the data, that data is specific for that use case. So we are doing an analysis for that system in particular. We can compare with other similar systems. So, for example, if we are manufacturing a piece that is used for a medical case, we can compare two different manufacturing processes for that same piece. However, if we try to compare a process to produce a medical piece and the process to produce an automotive piece, we are talking about different industries, talking about a completely different function, which because of that is not possible or advised to compare using the LCA. So LCA allows us to compare between similar systems, but it's not useful to compare with completely different industries.
There was another question from Victor.
Okay.
Yes,
Victor, you want to?
Yes. Can you hear me?
To ask?
Yes. Can you hear me?
We
I'm
can,
not
He
sure.
was with his hand raised.
Yes,
I'm not
at least I could hear you.
Sorry, we had no sound for a moment. Is it possible to repeat the question? Sorry.
Yes, sure. My question was about the computational power. Is it going to be something that will be included? Like, for example, the use of computational power to process the data and run the algorithms, because that's associated with the electricity at the end of the day used within the process.
That computational power is for the process itself in the, for example, the laser manufacture. Is that it?
Yes, not directly, but all the data that we need to work with, for example, and the algorithms we need to run. That will pop part of the process, not the cutting part of the process, but kind of the adjusting, the system adjustment.
Yes, of course, if we have data about that and it's directly related with the process, then it's something that we can account. So that computational power will require computers to run, which requires electricity, and so we can for the process, we can consider the electricity for the machines that will be producing a specific piece, but also then account for other electricity used for the computational models and that are run.
Okay, thank you.
Is there any other question? Okay, so I think we can go and look to at the software that we use.
Okay. So welcome to the last part of this crash course in LCA. I'm going to share my screen. So this here is SemaPro. It's the software we use to model, and I'm going to show you how all that João showed in Excel maybe modeled here with the program. So the interface is in Portuguese and the contents are in English. I will do my best to translate them. And so what you are seeing now is the first part of a project, which is to choose the libraries, or basically to choose our databases with materials and processes. And then, well, we chose EcoInvent, as Anna mentioned before. And then we can move on to the processes inside of those databases, which you can see materials with different categories. And let's show, for example, energy. So imagine that you are producing something in any country. You have like we can choose the energy for nearly every country available. In this case, we chose from Portugal. We can also consider transportation from several ways, like through boats, freight ships, planes, which we have to input the distance and it will do the calculations. And then for the olive oil, we define the process here inside agriculture, plant oils. And so these processes you see here are inside the library, but we can create our own processes, like the olive oil here. I'm going to show you what's inside. So this is the final product, which is 1 liter of olive oil. And then you can see the known inputs from nature, which are here. And in your Excel in sheet 1, it's highlighted in green. Everything in this, everything that I'm showing you is highlighted in green in the Excel. And you see that to produce the olive oil, we need the olives, which are produced in Spain, in this case. And then the materials and processes to produce or to refine the olive oil from those olives. Then here you have the known inputs from technology, but in electricity and heat. So we have medium voltage electricity with the electricity mix of Portugal and heat. And then here we have the emissions of the process, and finally the wastes like water and the bio-waste that João mentioned before. And for the process, that's it. This process is it's relatively simple. So the whole life cycle fits into this page, but in more complex processes, we can divide this in stages. So we can create three different phases. So this doesn't have a very long list. And after we input the inputs, we can analyze this. We go here, analyze. We need to pick the method, which in this case, it's the recipe midpoint and endpoint. And after this, we pick the unit, which in this case, it's 1 liter of olive oil, and we hit calculate. I'm not going to calculate right now because in this case, it takes about 5 minutes, and we don't want to look at the screen for 5 minutes doing nothing. So we already calculated beforehand here the results. No, not this one. Sorry, this is like not this one also. I knew this was going to happen. This is a comparison. Sorry, because this changes the order and it's awful. Okay, midpoint. So the results are these ones. We have the characterization which João and Anna mentioned before. So we see that for the impact category of global warming, the olive production, well, 100% it's the whole olive oil production, and the green, this green is the olive production, and we see that the olive production is the most impactful process. In your Excel, you have 4 impact categories. Here we have more, which we only did for the Excel to simplify. And then for the normalization, here we can, well, normalization allows you to compare the impact categories with one another. And we see that freshwater eutrophication is has the most impact. Well, and besides figures, we can also see tables. And we can see the tree of relations between every process, but it takes a while to calculate, so I'm not going to show you. And this was for the midpoint. Then we can do the same for the endpoint category. So we would, it's probably the middle one. No, I'm sorry, this changes the order. Okay, so we would go here and analyze and pick the methods, but instead of midpoint, we would choose endpoint and it calculate. And then the classic, okay. So exactly. Now we have the endpoint results. As we see again, it's the olive production, the light green, which is the most impactful stage. Then we have the normalization, where we see the 3 main impact groups of the endpoints: the human health, ecosystems, and resources. And the biggest impact is in human health. And finally, we can also compare 2 processes. So we can hit compare, and we can choose more than one process. So now I'm going to show you the results of comparing the regular olive oil production and the improved case, the one where João showed that also produces ethanol, or rather it avoids the production of ethanol. And by hitting calculate and selecting here the both processes, we would get, I need to close this. So close this. Well, okay, we would get this graph, which shows both processes side by side, and we can see those impacts for all the impact categories of midpoint in characterization, and then also in normalization. And yeah, I believe that's it.